Hello, everyone. Thank you so much for joining us for today's Spotlight series. Today, we're highlighting electrical and computer engineering with Professor Tony Levi, as well as Professor Keith Chugg. My name is Erin Tanaka, and I represent the Viterbi Admission and Student Engagement Office within the Viterbi School of Engineering. So I'm just so happy to have our professors who bring valuable expertise. So we just wanted to welcome all of you. And for those of you that are joining us for this session as a recording later on, just a couple of notes that, the presentation material today is valid as of today, which is April 1st, 2021. So just keep that in mind as we go through, as you listen to the presentation. But let's go ahead and get started. All right, so just one quick note. For those of you that are attending the session live, I will be sending a follow-up email with a copy of the slides. So there are some links, especially towards the end of the session. No need to jot those down unless you need them right away. And then, of course, for those of you that are watching the recording, if you ever need more information, feel free to reach out to us via email, and I will provide that contact information at the end as well. Throughout the session, for those of you that are live during the session, please use the Q&A panel to ask any questions throughout the session. If they are pertaining to that current slide, then we will be able to answer those aloud. If they're a little bit more personalized questions, I will be available to answer those individually. But we also will have an opportunity to ask any questions during the Q&A portion of the session as well. So for today's program, I will start out by talking a little bit about USC and the Viterbi School of Engineering. We'll then have Professor Levi and Professor Chugg talk about our master's programs in electrical and computer engineering. We'll go over some frequently asked questions, including, how our Jenna Viterbi online delivery method works, as well as I mentioned, a Q&A session at the end with all of us, so you can ask any questions that you have if they were not answered during the session. So a little bit about the University of Southern California, or USC. We are the oldest private university in the Western United States. We were founded way back in 1880. We currently have 46,000 students, our graduate student population outnumbering our undergrads. And we have over 4,700 full-time faculty members. And that, does not actually include many of our adjunct faculty and guest lecturers that come from a variety of different fields and industries, and then really bring their expertise to the classroom. We have very diverse student population. So we have students that span across all the nation, of course, and many countries, representing over 100 countries. And we are very proud of the fact that, there's a very diverse student population that you would be interacting with, whether you're online or on campus. And we are located in Los Angeles. So we are, if you're not familiar with the Los Angeles area, we're about a 10 to 15-minute drive from downtown Los Angeles. But we are right in the middle of all the action, whether you're interested in, of course, opportunities in engineering or technical professions. We are about a 45-minute drive, depending on traffic, from the Silicon Beach area as well. But beyond, the Southern California area, USC is very well connected with a number of companies and organizations throughout not only the U.S., but throughout the world. So about the Viterbi School specifically. So within USC, we are one of the largest and oldest schools within USC, and we are comprised of 8 academic departments, one of which is our Ming Hsieh Department of Electrical and Computer Engineering, which of course we're highlighting today, and our student population. So we have over 5,400 graduate students. That includes both our master's students as well as our both online and on campus. We also have our PhD students and our graduate certificate students. So as you can see, our graduate student population is the large majority of our students. And also tied to that is, we are a leader in funded research. So we have over 35 research centers, and we're constantly engaging in a variety of different exciting research areas. And, if you have questions about research, I'm sure, Professor Levi and Professor Chugg could talk about that in more detail in a bit. In terms of our faculty members, we have 189 tenure-track faculty members. We have 33 National Academy of Engineering members, which is one of the highest honors you can receive as an engineer. And we have over 90 National Science Foundation Career, National, and Presidential Young Investigator awardees as well. So now I want to introduce you to Professor Tony Levi and Professor Keith Chugg. So Professor Chugg is our Department Associate Chair for the Ming Hsieh Department of Electrical and Computer Engineering Systems. He earned his PhD in electrical engineering here at USC. So he is a fellow Trojan, and he is a professor of electrical and computer engineering. We also have Professor Tony Levi with us today, who is our department chair of Ming Hsieh Department of Electrical and Computer Engineering for electrical physics. He has a PhD in physics from the University of Cambridge. He is also the professor of electrical and computer engineering for electrophysics and physics and astronomy. So thank you, Professor Levi and Chugg, for being here today. So I do have some frequently asked questions that we want to go through. So first and foremost, could you tell me about USC Viterbi's Electrical and Computer Engineering Department? So Professor Levi or Professor Chugg, if you want to take over.
I'll say something about that. So welcome everybody. The Electrical and Computer Engineering Department focuses on making ideas work in the real world. So there's a piece that is to do with interfacing to reality. And then there's another piece that connects to software and other aspects that are sort of abstractions of reality. And so electrical engineering sits between those two, and it's the practicality of making that happen that we're engaged in, both in research and in education and those aspects. So the Viterbi School of Engineering leverages an ecosystem in Southern California. And you should learn something about that if you're going to come to USC. There are fantastic opportunities in the region. So learning about the region and what it has to offer, and in particular, is something that you should be aware of. So in this slide, you see USC in the middle near downtown. That's the University Park campus, but it's not the only activity that USC has in this region. There's the Keck School of Medicine up there in the north east, and you see a little bit further on there's Caltech. If you go in the opposite direction, there's ISI, the Information Sciences Institute, that's down in the marina. That's a USC entity, and there's also ICT next to the Army Research Lab in that you can see on that chart. And scattered around just about everywhere, there are high-tech companies employing students from the universities in the region, including, you see there, UCLA, and of course, we're going to be talking, of course, about USC. So a little bit about the wealth that is in the Southland. There are 10 million people in LA County. There are 3.5 million people in Orange County. The combined GDP is over $1 trillion, which means it's comparable to the GDP of Mexico, but with very few number of people. And it also means that there's a GDP per capita. That means every man, woman, and child economic activity of about over 80,000 per person, $80,000 per person. So if you don't see opportunity in that, then you're missing something important. USC Viterbi School of Engineering is ranked 12th for the best graduate engineering school in the USA by US News and World Report. And of course, we are a department, Electrical and Computer Engineering department is a department in the Viterbi School. Also of note, there is the school, the Department of Computer Science, and I've already mentioned the Information Sciences Institute and ICT. What I didn't mention was the High Performance Computing Center that we have at USC, where you have free access to high performance computing, which is pretty unusual in an academic institution. And at USC, we were smart enough to offer that for anybody. Next slide, please. So, as I mentioned, the Electrical and Computer Engineering Department is currently ranked 14th in US News and World Report. It has a large number of professors, over 60 tenure track full-time faculty. There are 300 PhD students, currently a little over 1,000 master's students, and over 300 undergraduate students. There's a large number of notable alumni who made the name for themselves after getting their degree at USC. Next slide. The department is named after Ming Hsieh. He was an alum from the department, and he's the founder, president, and CEO of Cogent, which was a very successful company and still is. And he is currently CEO of another company that does genetic testing. And he made a gift of $35 million to USC in 2006. At the time, it was the largest ever to name an engineering department in the United States. And he was elected to the National Academy of Engineering in 2015. So the benefit that we accrue from that is an endowment for the department that is used for all sorts of activities. Next slide, please. So, as I mentioned, one of the strengths of the department is its research and very diverse range of research activities here. Everything from solving problems locally in the LA region, you see down there on the bottom right-hand side, traffic. We have people working on trying to figure out how to improve traffic flows, and have access to databases in LA County and Orange County that look at in real time traffic patterns as they evolve. So there's a lot of work to do with solving local problems, including, you notice next to that freeway traffic, there's some power lines, and so smart grid activities. How do you get more out and make electrical grid systems more robust? Above, remember I mentioned at the beginning the Keck School of Medicine, where we do work on medical research, in this case MRI, and there's an effort there that brings new techniques to MRI imaging that we're developing in the engineering school, and eventually will be of use to our medical colleagues in at the Keck School of Medicine. You'll also notice in the upper left-hand side, more traditional electrical engineering activities, circuit design and chips. That's a very special type of ADC, analog digital converter chip. Which you see there, one of the world's unique types of circuits that have a big impact on the interface between the real world and the digital cyber world. Below that, you see some waveguides, optical waveguides, so silicon photonics activities. And below that, there's a black phosphorus-based mid-infrared detector, focal plane array, another activity in photonics that we have. The little picture that you see that says 5 nanometers on it is an extraordinary piece of technology that was developed in the department that is able to use light to detect the presence of single molecules and identify what molecules they are, so sensing modalities. So, you know, there's a lot of research going on, and when you're at USC doing your master's, you have the opportunity to attend seminars and get involved in understanding that broad range of activities and how it might impact your thoughts on what you're interested in doing going forward. Out of all this at work comes a lot of startup activity, a lot of entrepreneurial activity, and I'm going to hand over to Keith to say a few words about the startup companies, which will be the next slide. Okay, Keith.
Hello, everyone. Thanks, Tony. Thanks, Aaron. So, sure, yeah, I'm going to talk a little bit about finish up the overview of the department, then we'll talk a little bit about our degree programs, our master's degree program. So as Tony illustrated in his map, there's a lot of industry opportunities in the Los Angeles region and in the greater California, San Diego, Silicon Valley, and even Pacific Northwest. So the whole West Coast is a tech hub, and our faculty and our students are very involved in interaction with industry. And one way that manifests itself is through entrepreneurial activity among our faculty and our graduate students. So here's on this slide is a sampling of companies that have USC origins. So we have companies at the top there on the left is a company that's was doing hardware acceleration for machine learning algorithms. It was a small startup company coming out of Professor Peter Burrell's group, and it was started by one of his students that's been acquired by a larger company. On the top right is a company I started. We're not really a startup anymore, but this is a company down in San Diego. We build software-defined radios, mostly for military and public safety applications. We're a mid-sized company now, a couple hundred people. And then another semiconductor company, but on the RF, so analog circuits, ABTUM or Aptum, also acquired, a small company that was acquired. And then there are companies coming out of the more electrophysics area in our department, like the transient plasma systems. And then we have, as you saw, there's some activity in biomedical applications. So the Pulse Biosciences is a startup that's using electrophysics research technology and applications in the medical domain. And then Lively Sensors is a startup that comes out of the work in the magnetic MRI imaging research done at USC. And then we have basically these companies across the gamut that have started out of USC. On the bottom right, you see a company that is basically a mobile app development company, and above it, a company that does machine learning and AI for managing customer retention systems, customer management systems. So next slide.
Great. So thank you so much for that really insightful information. Also, I wanted to now talk about, or discuss the program. So, what electrical and computer engineering graduate programs are offered by USC? And can you explain the differences between the specializations offered?
Sure. So let me continue with this. So we have one kind of our standard master's degree in electrical engineering. This degree is primarily a course-only degree. Most of our degrees are course-only degrees, although there is a thesis option for students who are so inclined and can establish a research relationship with a faculty member. But I would say that the vast majority of students complete their degrees through completing courses. Another option in your courses is a directed research, so you can do some research without doing a thesis option as well. And so the MS in electrical engineering is our core program. It's our most popular program, and it's our most flexible program. So we'll go into the details of that. And then we have a number of specialized master's degree programs. And the difference between the MS in EE and these other specialized degree programs can be one of two differences. So one is that it could be that it's just a collection of courses with no extra units, but a collection of courses in EE that if you take that, you get this designation on your degree. So it's basically a restriction on the MSEE, but by restricting and covering these courses that are specified by these specialized programs, you get this specialized degree. There are a few of these programs that require additional units above and beyond the number for the MS and EE, which is 28 units, and or they require that you take classes outside of the ECE department, like in computer science or physics. Okay, so we can give a quick overview of most of these. First is the MS and EE. As I mentioned, this is our core program, and it has a minimum of 28 units to complete the degree. So you there's actually no strict requirement on the focus area in the department, but it's a good idea to take a cohesive set of classes in one area. So there are, we're a large department, as Tony mentioned, and we have many, so we have classes across the spectrum of the broad field of electrical and computer engineering. So below is a list of areas that you can take courses in. And many students choose to combine two of these areas. So for example, it's not uncommon for students to take like a signal processing concentration, but then take a couple of classes in digital circuit design. So they get that combination. And on the right are the more programmatic requirements, which is that you have to take 20 units in our department. 20 of the 28 should be in our department. 19 of the units must be taken at the 500 level. So both of those imply there's some other options, right? So you can take classes at the 400 option, at the 400 level. And a 400 level class is what we call a tier class. It would typically have enrollment of senior undergraduate students and first semester master students. So we have courses like in signal processing, digital signal processing that are pretty popular with master students. In computer networking, we have a class 450 that's widely popular with the master's program students. So it's not uncommon for a master's student to take a couple of 400 level classes, 1 or 2. But most of the 19 units has to be at the 500 level or above. So that would be the focus of your class. And the fact that you have to take 20 units in electrical engineering means that you could take 8 units outside of electrical engineering. And the last bullet there just says that your choice of these classes has to be approved. So for the most part, if you're doing well in the MSEE program, we will approve for you to take classes in, in outside departments. Those are typically like computer science, industrial systems engineering, maybe physics, maybe mathematics, other engineering departments, mechanical engineering. Typically, you're not taking a class in psychology or art or something like that. And all of those have to be approved, but it's mostly based on, does this make a coherent program for your master's degree? And are you doing well in the EE program as it is? Okay, so next slide. So this is one of the more popular specialized programs, and the longest standing specialized program. This is a master's in computer engineering. And you can see that this also has a 28 unit requirement, and it has this additional constraint on top of the MSEE that 20 of your units have to come from the following set of classes, which are in computer architecture, computer networks. There's EE 450 that I mentioned, and then VLSI, which is could be mixed signal, could be digital. Right? So this class, for example, if you wanted to, you could basically replicate this program in the MSEE degree program. You could just take the classes that would qualify you for the computer engineering program and get an MSEE. But if you really want your degree to say computer engineering, you can do this, but then you're restricted to follow these guidelines. Okay, next slide. Yeah, so this one's different. So this is a very similar degree program. It actually looks, oh no, this is the computer architecture. So this is more, it's another computer engineering focused degree with different or focus requirements of computer architecture, networks, and VLSI CAD. So I think the difference here is the previous degree in computer engineering had an emphasis on circuit design, and this one does not have circuit design. Instead, it has more on CAD and automated design tools. Okay. This is a computer networks program. Again, very similar to the others, that it has some requirement across fundamental courses and required courses. This is kind of typical of the specialized degree. This one has a minimum of 27 units. Probably that is something that needs to be updated as we go, because we recently have been transitioning from 3-unit courses to 4-unit courses. So we transitioned our MSCE degree to 28 units, and we should transition all of these also over to 28 units. So this is something that's likely to change in the future. Next. Electric power. So this is something that Tony mentioned, smart grids and so forth. And this is a class that combines across sort of system disciplines and electrophysics disciplines, learning about the infrastructure and the core technologies that underlie the power grid, but then also learning about control systems and more advanced smart grid technologies. Next. This is a new program, relatively new specialized master's program in machine learning and data science. So this is one of our more popular emerging specialized programs. And it has, like the others, it has a more structure than the master's degree program in electrical engineering. So we have foundational courses or fundamental courses that are in the areas of probably linear algebra and digital signal processing. And then we have a software requirement. So we lean on, currently in the program, we lean on computer science for operating systems, or our own 400 level object-oriented C++ programming. And we have another class in software design and optimization within our department. So you only need to select one of those classes out of the 3. And then we have classes in learning and data analytics. You see the 4 listed there. The one is in neural networks, pattern recognition, optimization, and machine learning classes. And so you take 6 to 8 units from there. And then we have a large number of elective courses, things like cloud computing, foundations of AI, applied natural language processing, database systems. Some of those are in CS. This is a program that we are currently in the middle of updating, and we've been mainly the direction that it's being updated in, and this is in the works, and will probably go in the books not in the not too distant future, is we've been making some more applied classes within the ECE department to cover software engineering skills for ECEs, and also classes in deep learning, specifically deep learning classes that are more project oriented. So those classes, if you look on the list of classes offered, you'll see those offered as special topics classes in our course listings. And those are EE 599s. And that's an interesting way to see what's going on in our department. Master students are more than welcome to take these special topics EE 599 classes. And I think currently we have one in sort of blockchain technologies, and then we have these software classes that I mentioned, the software engineering classes. So you can get a feel for what the current topics of interest for the faculty are. And those are, we also use the EE 599 system to prototype classes that we think might be good permanent additions to our program. Okay, next slide. Okay, so this is also a brand new specialized master's program in quantum information science. So one thing that didn't come up in the department overview is that our ECE program, our ECE department is very unique in that we have a set of quantum information theory, quantum information processing faculty, which is unusual for a ECE department. So we have 3 colleagues, faculty colleagues who are focused in that area. And that's in addition to our colleagues who are interested in quantum physics and applications of that in device technology, for example. And so it's a very active area of research in our department. And we have classes in, for example, quantum error correction codes, quantum information processing, etc. So we decided to make a specialized master's program around this. And again, this requires more units than the MCE, except that there are requirements that you take classes in certain areas so that you have an expertise in this. And so this one, as you might suspect, has requirements outside of ECE. You see there's requirement to take a physics 500 level physics class. And then in the core, you're also probably going to end up taking at least one more physics class. Okay. And then you can see in the approved electives, there's even chemical engineering classes, because the quantum information processing and quantum information science is a highly interdisciplinary field across Viterbi and outside of Viterbi as well. Okay, next. Sorry about that. This is another one in the computer engineering, but focused on VLSI design. So this is includes both digital and mixed signal circuit design and automated design tools. So again, circuit design VLSI is a popular area for our master's program because there's a lot of there's historically been a lot of employment draw from large companies like Intel. Intel, you know, in some years hires 80 people out of our master's program. So we have lots of specialized degree programs and lots of course activity in this area. Next. Wireless networks is another specialized degree program. Again, it's 28 units, and it's basically requiring that you take a set of core classes like the others. Okay, next. This is another fairly unique program in our ECE department. This is a financial engineering program. So this is for students who have a background maybe in economics, maybe in electrical engineering, some backgrounds in mathematics, all kinds of different people with all kinds of different academic backgrounds come into this program. And the goal is for us to educate them in the area of mathematics and systems perspective required to work as a quantitative analysis essentially in the financial industry. So you'll see a assortment of classes there in mathematics that are taught in the ECE department, in stochastic processes, in probability, and then some classes in ISE, which is industrial systems, and in the business department on finance and financial engineering. That is, you'll notice this one has a 30-unit requirement, so a little more units. Okay, next. So this is a program I have less familiarity with, but it's a dual master's program in MS and EE and in engineering management. So this requires 48 units, but you're getting 2 master's degrees. So I guess if you divide 48 by 2 is 24. So that's the draw is you get 2 degrees for 48 units. You save about, what is that, 8 units? Yeah. Okay, next. Okay, so Tony, again, on his map showed you that there's a lot of industry around the Los Angeles area. You're all aware of the large companies in Silicon Valley centered around Facebook and Google. San Diego is also a large tech hub, sort of led by Linkabit and eventually Qualcomm and spin-offs of those companies. And then, of course, the Pacific Northwest area around Seattle with Microsoft and others, and Amazon and Boeing. So you'll see here, we've kind of organized, this is just a sampling of companies that routinely recruit and hire out of our master's program and our bachelor's and our PhD program. And so on the left, you see the behemoths of the world, the Facebook, Amazon, Google, Microsoft, companies. They have a significant need for volume of engineering talent, so they recruit very heavily from USC. I think USC is the USC alumni make up the largest cohort of engineers, electrical engineers in Silicon Valley. So if you come to USC and you get a master's degree and then you go up north and you end up working at Intel, you'll meet a lot of fellow Trojans on the job and in the food courts. In addition to these large companies, we have traditional semiconductor companies like Intel, AMD, and more emerging companies like NVIDIA and FPGA companies like Xilinx. Those are all digital design companies. You have analog circuit design companies like Analog Devices, Texas Instruments. You have companies like Qualcomm that are on the border of semiconductor companies and communication systems and networking companies. Cisco is a similar, you have software services companies like Oracle. You have service providers like Verizon. We're seeing a lot more activity on companies focused on autonomy and robotics. So companies like iRobot, Waymo, Lyft, Uber. We have a lot of software startup companies that hire out of CS, but they also hire out of ECE if you have good software skills. So Twitter, Snapchat's corporate headquarters are over in the Marina Del Rey area near USC as well. Airbnb. We have companies that are instrumentation companies that need a lot of electrical engineers, like Keysight Technologies, that's former HP Instruments company. And companies like MathWorks that make MATLAB, they also hire a lot of electrical engineers to help implement the processing algorithms that are so powerful in packages like MathWorks. We also have companies where we're at the center of the entertainment industry here too in Los Angeles. And so we have the large entertainment industries are here. And in particular, Walt Disney has a large engineering center in the Glendale, Burbank area. And they hire a lot of our USC students there to go work on things like ride design. Ride design is a big area in the Glendale location. And then we have the traditional aerospace companies that are aerospace and defense. There's a large co-location of those companies in what we call the South Bay region, which is down in Manhattan Beach, El Segundo area, not too far from USC. And then we have, related companies that are doing more commercial applications instead of just defense, like SpaceX, which is also located in Los Angeles. And, I'm sure you've all heard of SpaceX and saw see their exciting exploits. They need a lot of engineers to carry that out, and we are a resource for that. There are many other areas like Amgen I have listed there. They're a biotech company out in Agoura. And then there are also companies or organizations that are nonprofits that are focused more on government research and support. So Aerospace Corporation, Jet Propulsion Labs is just north of Pasadena. And even government organizations like DARPA, and Tony mentioned the Army Research Lab has a facility in Los Angeles. It also has its main headquarters back east, but they also hire our graduates. So that's just a sampling. Basically, any company that you can that you've ever heard of is here. We have lots of startup companies as well. I listed one there, Samba Nova. They build machine learning accelerators. And I was on a call with them last week. It was just random. There were 4 people. 3 of them are USC alums. So we're very present in both the large company, traditional engineering, and smaller active startup companies. And each year we have a Viterbi career fair where hundreds of these companies come, and they all set up booths out in the quad area. And the students, all come rushing with resumes and flash interviews. They have all kinds of activities that put you in contact with these companies, and you can get, obviously these are for permanent positions, but also the students are looking for, and the companies are often looking for internships. So during your master's program, you may even be able to do an internship with a company. Okay.
Thank you so much,
Sure.
Professor Chugg. That was very helpful, very insightful. And so, now I want to move on to, talking about the delivery method. So, can I pursue an electrical and computer engineering graduate program online? So the answer is it depends on the individual program. As you probably saw on each of the individual slides, there was a note, a computer screen that indicated that the program is available online via Viterbi as of today, which is April 1st. And so a couple of methods of delivery that you have at your as options. So first and foremost, we have our on-campus students who tend to be full-time, although it can vary, but typically those students are taking 2 classes per semester, sometimes 3 or even 4, depending on the course load that they can handle. But typically, because of that course load, they're graduating about 1.5 to 2 years to complete their degree. So, and those that are wanting to complete their degree in about 1.5 years, it does often require, or for the most part require, courses in the summer as well. But for, the online Gen of Viterbi delivery method, you are, because I would say the large majority of our Gen of Viterbi students are working full time, they tend to take 1 to 2 courses per semester, but it is flexible as long as you complete your degree within 5 years with the ability to petition for additional 2 years. It really is up to you how you pace out your program. But on average, our online students are graduating about 2.5 to 3 years. So, how Gen of Viterbi works. So we recognize, there's a lot of different online delivery and everyone currently is online, but, we started Gen of Viterbi way back long before, everyone else was online. We actually started even before the online platform was available back in 1972. So almost 50 years at this point that we started with, video recordings that would get sent over to company locations that were not even very far away. But in terms of, how it works, so the way that it works is you are in the same exact classes as the on-campus students. So you can watch the lectures live as they're normally occurring on USC's campus, which allows you to engage during the live session and call in and ask your questions. But we recognize not everyone can attend a live session. So whether it's a work conflict or a personal conflict, you also can watch the lectures on your own time asynchronously. So there are course recordings of each of the lectures that are available in the course archive that you have until the end of the semester. So it is very flexible in terms of, how you watch the lectures. In addition, if you are, not too far from USC's campus or ever visiting the Los Angeles area, you are more than welcome to come to campus. You have a seat in the classroom. You have access to all the same campus resources as the on-campus students, so there's no difference there. And, I'll talk about some of these things on the next slide, but, just so you know, in terms of exams, if you're in the Los Angeles, Orange, or Ventura County, you would take your exams on USC's campus. Otherwise, you would take your exams at a proctor location that's convenient for you. And we do have a dedicated Gen of Viterbi exam proctor coordinator that, finds a location that works and is convenient to wherever you're located at the time of the exam. So this gives you a side-by-side comparison. I recognize some of you are undecided about, online versus on campus, but your program admission is exactly the same. The required materials are exactly the same. The weekly course lectures, assignments, exams are exactly the same. It just depends on, how you are taking them. So again, we talked about, the ways that you can engage in the lectures, but on-campus students are expected to attend the courses on USC's campus, and they do have access to the course recordings, but only if there's a Gen of Viterbi student in the classroom. And, talked about, courses per semester. Degree completion requirements are exactly the same, 27 to 37 units. with a 3.0 GPA or above. And because, the curriculum, the mission, graduation requirements, assignments, et cetera, are all the same, you are earning the same exact diploma, whether you earn the degree online or on campus. There's no distinction in a degree whatsoever, as to what your delivery method is. The same exact degree awarded. So next question is, I've decided to apply for admission. Any tips on getting started? So, first and foremost, you'll want to make sure that you confirm the application deadline. So, while fall 2021 and the deadline has passed for on-campus students for scholarship consideration as well as the final deadline, we are offering an application extension deadline for Dana Viterbi for those that would like to pursue their program online via Dana Viterbi. So, for those of you that are interested in that delivery method and do not require a student visa. We do not actually grant student visas to any online students, so that's only for on-campus students. But if that pertains to you, so if you would like to pursue your program fully online via Dana Viterbi, we do encourage you to email us at danaviterbi.usc.edu to find out more about the details for the extension. Additionally, spring 2022 is the next application deadline for everyone. So the scholarship consideration that's specifically for on-campus students is going to be August 31st, and then the final deadline is going to be September 15th. So again, the next step is really to review the application criteria. And, as you saw, there's a number of programs and specializations. So we do encourage you to go to the individual program page or pages that you're interested in. You will see that there is an application information tab, and that will include the admission criteria and as well as application requirements for that particular program. So to get started, we do encourage you, for those that are interested in pursuing your program on campus, we do encourage you to virtually explore our USC's campus currently and then start your application for formal admission. For those that are interested in pursuing the program online, you can also start your application for admission. If you are also interested in what's called limited status is a way to get a jump start in taking courses as early as summer 2021. And it's limited in that, you can only take 12 courses and you would need to have an undergraduate GPA of a 3.0 on a 4.0 scale with an engineering, math, or hard science or related field. But if you want more details about that, I can send those over to you. And also, if you're interested in read those requirements, you can complete the Dana Viterbi profile to find out whether or not you are approved for as a limited status student. All right, so we do have a number of questions, so thank you all so much for your patience. I appreciate that. So some questions that we have here. The first one is, the first one I see here is, will the quantum program be available online in the future? I think you're muted.
It auto mutes me. I think some of the classes will be available through DEN, but I don't think that, since it has requirements in the physics department, those classes are typically not on DEN. So it may be a situation that where if you're, say, working in Orange County or San Diego, you could take some of the classes through DEN, the ones that are in ECE potentially, and then, but I'm not sure that we have plans to offer it fully through DEN in the near future because of the requirements that for the physics classes. If it turns out to be a wildly popular class, I'm sure that would impact the decision, and physics would be happy to put some of their classes on the engineering DEN system.
Great, thank you. Another question is, how does the master's in machine learning and data science compare to the one from the computer science department?
Sure, that's a great question. So first of all, if you want to do a master's degree in the computer science department, you have to have an undergraduate degree in computer science, or they put you through what I don't know the term they use, but it's a sort of a transitionary program. So you can enter a program that is a master's in CS for students who don't have a CS undergrad. And then I think it's an additional 8 or 6 units that they put you through, which is kind of a crash course in CS before you take the typical degree program. So that's one difference. If you have a degree in ECE, then you can enter directly into our program, and it's more difficult to enter into a CS program. But more generally, there are cultural differences and style differences between EE and CS. So for example, in our MLDS program, we start everybody off with a graduate level course in linear algebra and a graduate level course in probability. And those are just foundational core topics that you can't really learn what's going on in machine learning without understanding that. It's just like, it's like trying to build a car without a wrench. And so CS doesn't do that. What they do is they kind of throw you in the deep end in some sense, and you learn the probability and the linear algebra that you need as you go. And so I think that's kind of the cultural difference. A cultural difference between EE and CS is the whole core idea of CS is to abstract things. So it's like, how do I use this thing instead of how does it work in the low level details. Now, of course, if you take a CS class, you're going to also learn how it works, and if you take an EE class, you're also going to learn what to do with it. But those are kind of the philosophical differences. Another main difference is that our program also has an emphasis on electrical engineering applications and on, in particular, time series analysis. So you'll see that another requirement for our class is you take a digital signal processing class right away in your program, and there's no such requirement in CS. And CS typically is not focused on time series analysis. And when in ECE, we're concerned with data that comes from real world sensors. And those typically have a time component to them or a spatial component to them. So we're typically interested in processing video in real time on an embedded system. That's something like that would be an ECE MLDS problem, whereas computer science might be more focused on problems like general knowledge representation and natural language processing would be a little bit more in their domain. But there's definitely a large overlap, and we have students that mix and match the classes across CS and ECE. When I taught deep learning, I had some CS students in there, and some of our classes, there's a deep learning class in CS, and some of the ECE students will take that class as well. So hope that
Great.
helps.
Yeah, that was fantastic. Another question is, for classes in mixed signal, are there traditional lab components that are available or required, such as undergrad, where you would have DC circuit theory and then one credit lab component?
This for classes. Typically, those classes where you would have DC circuit theory and one credit lab would be below the 400 level. So those, I think that's like a 202L in our program. And when you're a master's student, you can't take classes for credit that are below the 400 level. So I mentioned you could take 400 level. There's some limit on the number of 400 level classes you can take, but you couldn't take, for example, a 300 level class and count it towards your master's degree. You could always, ask to audit the class if you want a chance to brush up on it. If you mentioned you come from a non-traditional background, so if you wanted to brush up on that material in the context of a lecture lab environment, you could talk with the instructor, and there may be opportunities to informally audit the class, but you can't count it for credit.
Great. And I think the last question we have here is it possible to transfer into specialization after starting your studies as an MS in electrical engineering student?
Yeah, that's the question. I do not have the 100% official answer to that, but my sense is that you can, but obviously you have to watch out to make sure that you're covering the core requirements for the degree program. So you don't want to have banked 18 units and then decide you want to do the MS in quantum information sciences, and you've got another 24 units to do afterwards. So if you want to do it, you should do it as soon as you maybe after your first semester. In particular, like in the MLDS master's program, we do allow students to transfer in, but we have some we have some requirements for that, GPA requirements in the core classes. So we have in that program, we have a separate admission pool for that. We do the admissions completely separate. And then when students are here, if they're not in the program, but say they've taken the probability, linear algebra, and signal processing classes, and they've maintained excellent academic performance in those classes, then they can transfer into the NLPS program. So I know it's true in that case. I suspect it's true in all cases, but you have to manage your credits to make sure that you don't end up taking a lot of extra courses.
Great, thank you so much. And I think these last questions I'll just answer really quickly. So the question is, is the top GRE score a priority that I should be shooting for? And, the answer is actually, so first and foremost, for fall 2021, the GRE is actually not required. And so we are waiving that requirement due to the challenge of the pandemic. And then for future semesters, you'll want to check back with us. You can email us, and I'm actually going to share the contact information here. But, for updates, we do encourage you to reach out in a couple months to determine whether or not that is required for future semesters. For the spring applications, that's going to be open within a couple months. So you can also check back closer to the summertime when the application will be open as well. But, I wanted to say thank you so much for all of your questions. I recognize there's a couple that are more individualized, so I will be able to answer those as well. But if you have any questions after this session, or for those of you that are joining or watching the recording, for those that are interested in pursuing the program on campus, you can email viterbi.gradadmission@usc.edu. For those of you that are interested in pursuing your program online via Dana Viterbi, dana@viterbi.usc.edu goes to myself as well as my colleague. We do, respond within a 24-hour period on normal business days, and you can also email us to schedule a time to discuss your questions. But I do want to thank Professor Chugh and Professor Levi for joining us for today's session, providing so much insight and knowledge about the programs. Very helpful. We hope that everyone on this session gained a lot more insight into their program areas. And so thank you so much again. Thank you all for taking the time out of your busy days to join us. But take care. Hope to hear from you soon. And as we say at USC, fight on.
Bye-bye.
Bye.
Bye, everybody.